Uh, Thank you very much for everybody for joining in. Today we have a very special guest all the way from the UK, Paul Johnston. Paul has been Paul is a security consultant at Pentest Limited. And as it happened, he happens to be my first boss who offered me a security job. And Paul is specialized in web application security, and he has over 25 years of experience in developing as a sysadmin, as a pen tester, as a security consultant, and a security tools developer, and as a government contractor. So Paul is here today to talk to us about application security, what goes on inside the mind of a web application hacker. So without further ado, over to you, Paul.
Thank you, Lasse. And again, thank you for inviting me to speak to the group. So I work primarily as a web application pen tester. And what that means is using the same sorts of techniques that hackers use to attack web applications. I use them to try and help the owners and operators of those applications to manage them in a secure way. And so to do that, I need to get inside the mind of a web app hacker. And what I will try and do today is share with you some of the techniques I use. So I'm going to go through a few introductory slides, but the majority of this talk is going to be hands-on demos using various lab environments that I've developed. Now, you will almost certainly be familiar with the recent headlines related to data breaches and information commissioner fines, and all the other impacts that companies can have when they make mistakes related to personal data. I guess the majority of these headlines are UK specific, but the underlying message applies wherever you are in the world, in that it is a dangerous world. Attackers are using increasingly sophisticated techniques to try and breach organizations, and the expectations of regulators and customers are getting higher, so that you really need to have done all the things you can reasonably do to secure your applications, or unfortunately you could end up being a headline just like these companies. And the other thing that I think is pertinent is how crucial web application security is. I've drawn here a diagram, and for a typical web application, on the front side, it's exposed to the whole internet. So that's where all your business partners and clients are, but that's also where the attackers and the phishers and the fraudsters are. So inevitably, just because of what a web app does, is exposed to all this risk. And then at the back end, the web application's connected to the internals of your organization. Even if you've got internal firewalls that mean it's not connected to your actual office network, just by nature of its function, it's going to be connected to other sensitive systems. And the only thing really that's mediating the dangerous internet from the sensitive private network is the application itself. And this holds even though organizations have got all sorts of infrastructure and operational security. So, you might have TLS encryption and use, strong AES encryption. You might have a web application firewall. You might have intrusion prevention systems. You might have a security operations center. You can have all of those things, but they are only partial mitigations. The web application itself is the key control. And quite often, I see organizations that have all these defenses, but just one coding error on one line of a critical application can lead to a breach. Now, there are three main things that I see organizations do to defend their applications. So I've listed the highlights there. So the first is architecture, which is structuring your application in a way that it's as defended as possible. So making those choices about installing a WAF or an internal firewall, potentially compartmentalizing your app into microservices, making sure that least privilege is applied so that each user, whether it's a human user or a system user, has got access to the absolute minimum they need. And also selecting the technologies you use, in particular, modern development frameworks tend to have more security built into the framework than older ones. And once you've created a secure architecture, there's also the whole question of awareness. And this covers all sorts of different people. So it goes from end users to technical staff within your organization and also to management. But particularly around the technical staff and the developers, there's all sorts of awareness that can be created, such as secure coding standards, sending on developers on security training courses, and also cultural changes like appointing security champions within development teams. And then once you've got a secure architecture and that there's good awareness of it, the third prong is to audit, which is to confirm that the application that's been deployed and operated is truly providing the security controls that's intended. So in general, organizations need to do all three. Now, my work is primarily in the audit part of this. I do give clients guidance on architecture. I do run awareness sessions, but my work is primarily about auditing web applications. And there's three main techniques that this can be done. So static application security testing, or SAST, is about reviewing application source code. So whether this is done by a manual review or by automated tools, it's all about taking the source code and assessing how well coded it is and if it's in line with the security requirements. Now, dynamic application security testing, or DAST, this is about looking at running applications. So the dynamic and static difference, the idea of static is not running. So dynamic is closest to what hackers do, and that's the majority of what I do in my role. And then the third type of audit technique is instrumented application security testing. And this is where you install instrumentation into the application runtime. So it might involve putting an agent on the application server, which can hook into various API calls the application makes, and do things like tagging variables to indicate if it can contain untrusted data. Now, ideally, organizations would do all three. In practice, what I find is if an organization is doing just one of these to any depth, they're normally doing pretty well. If they're doing two of these to some depth, they're doing really well. And it's quite unusual that I'd see an organization that does all three. But these are the three main techniques. And DAST is what I tend to work within. And I'll just expand a little bit more on that. So DAST is about taking a hacker's eye view. It's about assessing an application in the same way a hacker would do. And there tends to be three main steps to this. So first of all, we explore the application. So we go through the application and find all the functionality. Start from the front page, look through the whole application, look at what functionality is exposed to different users, look at maybe what particular types of data within the application expose particular functionality, and also look for things like test files that have been left after deployment. And doing a thorough explore is important because what we quite often find is that the majority of an app may be well defended, but that you will have some rarely used feature in some corner of the application which is vulnerable. And despite the feature being rarely used, if a hacker is able to find that, they may well be able to compromise the entire application. Now, once we've explored an application, the next step is to audit it. So this is to find potential vulnerabilities, to find behavior that appears to be out of line with expectations. So this is where we start injecting unusual characters. We know that SQL queries tend to delimitate input with a single quote. So we try sending inputs with a single quote. We try injecting HTML tags and file paths. And we see how the application behaves, and we look for behavior that indicates vulnerability. And it isn't just about injection attacks. This can be about access control issues. It can be about many things, although I do find that injection attacks and access control issues account for the majority of the high risk issues that I found. Now, some clients will be quite happy to just take the output of the audit phase and just say, okay, you found some behavior that looks like it could be exploitable, and we'll fix that. But where we get to have a bit of fun pen testing, and of course where a real hacker gets to do a bit of damage, is exploiting these issues. So the audit might show up that a single quote causes an SQL error message. When we try and exploit this, we start trying to maliciously extract data from the database to tamper with data to escalate our privileges. The audit phase might show us popping up an alert box to demonstrate cross-site scripting. The exploit phase is where we go and target a user, extract their session token, and compromise their session. So those are the three phases. And now what I was going to do is, using some lab environments, I was going to demonstrate this. Now, I am working live, so I'm going to hope that everything will work reliably. So Okay, so there's actually two different lab environments that I'm going to be demoing. So this one here is something that we use for our secure coding training. And this is running locally on my laptop. And then this one here is running on the internet. This is xssy.uk. So this is one, if you're interested, you can just log on. It's completely free to sign up and use. And it has a wide range of cross-site scripting labs. Okay, so within this environment, we've got a few labs for SQL injection, and I need to be logged in here. But it's just with a test account. Because I'm using a test password, I've just been flagged up as using a very weak password. Okay. Now, the first thing that I'll do to start investigating this application is I'll use a tool called burp, which is an intercepting proxy. So this is the tool, and what it lets us do is look at the raw requests and responses that go across the network. Now, to use this, I need to configure my browser to use the proxy. I'll do that here. Okay, so now when I reload this page, so I'll just, you can see 471 is the last request. So when I reload this, you can see we've got another request here. And it lets us look right down at all the bits and bytes that have gone across the network. So all the HTTP headers, cookies, and it lets us look at the response. So the HTML headers, the HTTP headers, and the HTML content. Now, this locally running lab environment does not use SSL. Now, we hit a little bit of a bump in the road because the xssy.uk does use SSL. Now, I refresh this, because burp's trying to intercept the encrypted connection, we get this warning that our connection's not private. Now, we can do something about that. So we can actually download the certificate that burp uses. If I go into my internet options, I can import the certificate. And I can import it as a, sorry, that's wrong, as a trusted root CA. Now, before Windows will do this, it's just warning me that there is a significant security impact from doing this. And of course, we shouldn't blindly click through such security warnings. But in this case, because we're doing this for test purposes, I am going to say yes to that. And I will just try reloading that. Okay, I think I may have to just restart my browser. Okay, there we go. So we're able to access XSSY through BERT, and we can see here that we've intercepted the requests and responses. And if you look there, you can see there's the HTTPS and the URL. So we are now successfully intercepting the traffic. Okay. So just to show you the process of doing this. So if I go onto this lab, so this lab's got 50 pages, and the rubric tells us that one of them's got an XSS vulnerability. So we will get on to automation in a bit, but to start with, what I do is I start clicking through these pages. And if I go back to this tab, I can see, so you're getting page 1, page 2, page 3, and you can look in here. This gets filled up quite quickly. But you can see within the lab, you can see in black are the pages I've actually visited, and in grey are the pages where BERT has detected it because it's detected a link, but it's not yet been visited. You can see, although there's a stub request, it's just greyed out to show it's a stub, not as in this one where it's a true request. Okay, so the explore phase, it's a case of going through the app and looking for functionality. And we can also use tools like this. So I won't actually run this now, but what this lets me do is have a list of common file names and check the site for all of them. So if there's something that exists but isn't linked to, I can, if it's got a common file name, I can pick it up there. Okay, so that was just a little introduction to the explore phase. Now, let's have a look at this. So, in this lab, we can see we've got this table, which has got a list of statuses from different people. And it's got a search facility. So, if I just maybe I'll start by picking something that I know doesn't exist, which I search for that, finds nothing. If I maybe grab a word that I can see exists. Okay, so we've got a little feel for how this feature can be used. And if I look in Burp, I can see these raw requests. Now what we can do is we can use the Burp scan functionality. And you see the target there just went red. So that indicates that we've just found something high risk. Okay, so there's clear text submission password, but we're less interested in that. But what's very relevant here is SQL injection. So it says the search parameter appears to be vulnerable. to SQL injection attacks. See that it sent this search string with a single quote, and it's a little bit hard to see it here, but it has the response is getting SQL error message. Okay, so let's try putting that in. Okay, now that hasn't caused an error message, but what I do notice is up here, percent 27 is a URL encoded single quote, but we've got two. So it looks like there's been some validation that has doubled that up. There we go. So we've now been able to trigger the error message. Now, the lab is asking us to find a hidden status. And actually, if we look in the error message, we can see there's a little snippet of the SQL. So select star from status where hidden is false and message like this. And because we've been able to put in a quote, we've confused it. We've actually made it think that that's the end of the string. So what I can do is do or 1 equals 1. Now I just need to do a plus instead of a space because of how URLs work. So let's try that. Okay, now we've still got an error. We've got the or 1 equals 1 there, but do you see from after the string we were injecting to, we've got this little bit of extra SQL that we don't want. So what we can do is put a double dash, which is an SQL comment. We do that, so we've got no error message, and you can see we had these two statuses previously, but there's now a third status that presumably was hidden before, and it's telling us what password on the zip file is. Okay, so injecting or 1 equals 1 is one of the simpler ways to exploit SQL injection. Now, number 2, it's asked us to give the contents of the token column. Now, I don't really want to do any more complex SQL in the URL bar. It's just not designed for that. Now, if I go back to Burp, now we've got this query, this request, where we queried for food, and I can send that to Repeater. And this is a tool that lets me manually edit and send requests. So I can go to foo and send it, and got the error message. Now, if you remember before, I was doing or 1 equals 1 with pluses. And that still works. Now, if I do use spaces instead of pluses, now what's happened there is I've completely confused the HTTP parser. What we can do, because what ideally I would like to do is develop this attack without URL encoding, have Burp code it for me. So what I can do is I can select this text, and then I can use this Burp extension called Hackverter, and I can encode using URL encode. Now, you see, when I send that, payload has worked. And what's happened, burp has URL encoded between these tags. And if I look in the logger, just go all the way to the bottom, you can see that's what was actually sent to the server. So this is going to be a much nicer workflow because we don't need to think about URL encoding. Now, the contents of the token column on the flag table. Now, rather than all 1 equals 1, what I'm going to try doing is union select. Just to start with, I'm going to try selecting nulls because these tend to avoid type conversion problems. And I can see there's 3 columns here, so it might be a reasonable guess that there'll be 3 columns in the query. Okay, so I've got an SQL error. And it's saying column count does not match. Okay, well, maybe there's 4. Okay, and now we've not got an error. We've also not got any data here, but that suggests it's 4 columns. And then the next thing I can do is try putting some string data in each one. Okay. So we can see that columns 2 and 3 get included in the output. So what I can now do, because we want to select the token, we can put token instead of 2 and from flag. You can see there that the token is extinguish harmony. Okay, so we've solved part 2 of this. So first of all, we got a row in the table we weren't authorized to see. Now we've got a column in the table that we weren't authorized to see. Now the third step is to get a column from a different table. Now I could use the same sort of approach to do this, but actually what I'm going to do instead is use a tool called SQL Map. Now I'm going to start by grabbing this request. I'm going to paste it into a file. And now I'm going to run SQL Map on that request. So it's detected it's an H2 database and it's asking me about skipping other payloads. Okay. In fact, I'm just going to take all these defaults. Okay. Now, having run it once, it's learned a little bit about the backend. So the next thing I'm going to do is say man's tables. And this is going to extract a list of tables in the database. And there we go. If we just look back here, it says the table name begins with flag. So I think this here, flag Dakota, is the table we're looking for. What I can do is I can tell it to dump table, and we're only interested in this one. So if I say flag, there we go. So the flag is yellow comet. So I hope that shows a little bit about the process of finding and exploiting SQL injection. So we can access rows we're not authorized to, we can access columns we're not authorized to, and tables we're not authorized to. And just to show you a little bit more, this is actually the vulnerable code So you see it's building up an SQL query. And it's taking this this search query from a request parameter. There's no validation. It's putting it straight into the query. And because there's no validation and it's being used in an unsafe way, the query is injectable. Okay, so having looked at SQL injection, let's take a look at cross-site scripting. So I'll start right at the beginning. So this is basic reflective XSS, and I can launch the lab. So this is, excuse the solutions coming up in autofill. So the lab is asking us to enter our name, saying hello. And if we look at the source, we can just see our input is being reflected to the output. Now, the obvious question is can we put HTML characters in here? Okay, well, the italics tag, it has caused a visual effect. If we look at the source, our HTML tags have come through. So the next question would be, okay, can we put actual scripts in there? And there we have, we've done that successfully. Now, most of these labs on this site, the objective is to run the function alert document.cookie. And so now we've done that. We, of course, have just done that on our own browser. But what this site lets me do is I can submit a URL. And what will happen is in the background, in the cloud, in a headless browser, the site will simulate a victim clicking that link as if they'd been emailed it with a bit of social engineering, encouraging them to click the link. So I can send that off. And there we go. So we've managed to cause an alert in the headless browser. And in doing so, we've solved the lab. Now, there are all sorts of variants of cross-site scripting. So if we look at this one, so just like before, and try my name. Now, the next thing to try would be, can we get HTML tags through? Okay, so an initial assessment of this would be that it's not got through, but let's have a look at the source code. Okay, now there's just a bit going on here because this is our payload. And you can see that the less than has been replaced by this string ampersand LT semicolon. So there is some sanitization going on here. And it's actually, the context of it is in this JavaScript string, which is stored into the name variable. And then later on, that's printed to the document. Okay. So less thans are sanitized. But what happens if we use double quotes to break out the string and then a semicolon, and then we'll do alert document.cookie. And then similarly to how we did in our SQL injection, I'm going to put a comment in so that our payload isn't corrupted by characters that are trailing. go. So we've got the pop-up, and let's just have a look at this. There we go. So our payload was that. And it's just double quotes terminated the string. We've put our own JavaScript in. It pops up on an alert. And then similarly, let's try this in the headless browser just to confirm. Oh, pardon me. I've left the use source. Okay, so we've solved this lab as well. And I just hope me going through that process gives you a bit of an insight into how we refine payloads to achieve successful attacks, even when there's partial sanitization, even when the app's taken some steps to secure itself, but that those steps are not complete. Okay, so those two examples, we got as far as popping up an alert box, but that is some way short of conducting actual malicious exploitation. Now, there is a lab here, capture cookie. So this one, it's got a different objective. We are to capture the flag cookie. Okay, so let's start by launching the lab. There's a little bit of rubric suggesting we use the access log on our payload hosting lab. And we'll come to that. But first of all, let's just try a basic payload. Okay, so this looks like it's trivially vulnerable. We can see that this is reflected with no sanitization. Okay, so first of all, let's try an alert box, and that's successful. Okay, now let's have a look at our payload hosting. Now, you can see at the bottom of this page is our access log. So if I just preview the lab, when I go back here, you can see my browser's request to index.html has been logged. So if I put something in here, foobar, okay, the file's not found, but the request is logged. And this is useful because this gives us a mechanism to extract data. What I'm going to do, I'm going to, instead of creating an alert box, I'm going to create a new image. I'm going to set the source code, the source URL. Sorry, I'll just close the script tag. What I'm going to do is set the source URL to be my payload hosting lab. And then what I'm going to do is append to this document.cookie. Okay. Right, so nothing visually has happened, but let's have a look in our access log. And you can see we've captured the cookie called flag. Okay, now at this point, we've just captured a cookie from our own browser. So what we really need to do is take this exploit URL and submit it to headless browser. So we'll just give that a few seconds. Right, so the payload's been submitted. Let's look at our access log. So we've got another flag cookie. Now this one is not from us. This is from the headless browser. So let's grab that. And here we've got a box where we can submit this cookie. And there we go. We've successfully solved the lab. So I hope this is illustrative in showing that cross-site scripting is not just about alert boxes, that we can do truly malicious actions. We can capture client session credentials, and from there we can impersonate victims and do malicious acts. Okay. Now, I just wanted to show one more of these labs, and this is Unicode XSS. Okay, so I'm going to try our basic payload, so the italics tag. Okay, so it looks like it's been sanitized. If we look at the source, that does appear to have been sanitized. In fact, I'm just going to try another payload, just without any, well, another submission, but with no sort of special characters in it. Okay, so submitted that. We can look at it in BERT. What I can do is I can scan it. Now, what I'm going to do, just going to create a new scan configuration. What I'm going to do is I'm going to turn everything off. I'm just going to turn on scripting. This is just for performance. Okay, so it's completed that, and it's found no issues. So Burp Scanner, and bearing in mind this is like an industry-leading scanner, has not been able to find any cross-site scripting on this page. Now, there is a little clue in the name of the lab. And what we can do is we can use these characters. So this is a Unicode full width less than sign. I'm going to take that, paste it in, and take the greater than sign, paste it in, put an italics tag. You can see that there is a slight visual difference here. And now we do see italics. And if I look at the source of that, what I can see is a regular italics tag. Now, this is not a super common vulnerability. And I just want to point out that what's happened here, it's not just that these characters were reflected, because if they were reflected unchanged, we'd see a full width less than sign there. And the browser would not interpret that as a tag, and we wouldn't see italics. What's happened is there has been a particular type of Unicode normalization. I think it's a form called NFKD. And this does like a compatibility normalization, which means it takes some of the funkier characters like full width less than and converts them to more common characters. And one place that you may particularly see this in the wild is with the use of SQL Server. Is if you try and store a Unicode string in a varchar column, and varchar columns are non-Unicode in SQL Server. If you try and do that, it will do this NFKD normalization, and this can, in some circumstances, lead to cross-site scripting. So let's just finish that. So let's do script and end script, and we'll do alert cookie. There we go. We've got the pop-up, and if we go back here, we can submit it to the headless browser. And there we go. We've successfully solved that lab. Okay, so I hope that's illustrative of some of the things that you can do around cross-site scripting. And just keeping my third eye on the time, I just wanted to show a couple of access control issues. These are quite simple examples, but actually you would be amazed how common these simple examples are within large, complex modern apps. So we've got here, similarly to before, we've got these status messages. So got this one from Jade, right? And we can click on this. Apologies for the terrible humor in these. Okay. And if we look closely, we've got ID equals 1 in the URL. And then there's this message from Ewan Summers. Again, if we look close in the URL, we've got ID equals 2. What happens if we change that to 3? Right. So we've now got access to a message that we are not supposed to. We can see links to message ID 1 and 2, but by tampering with the URL, we can get access to 3. And we can keep going. So once we get to message ID 5, we've got this message from Julian Assange, and it's got the flag. Or if we were doing these labs in a kind of competitive scenario, what we'd be doing is, as we found these flags, we'd be calling them out, and the facilitator would be keeping track of who called out the flags first, because it's a way you can prove that you've done the hack. It's not just, we're not just taking someone's word for it. So what should, of course, happen is that ID should be validated. It should be confirmed that the requesting user is authorized to view that message. But in this case, that validation wasn't done, and it results in a security vulnerability. Another variant of this is forced browsing. Okay, so we're logged in as Alice, and we can see these two functions. You can see CSRF and parameter tampering. Okay. Now, let's have a look at the source code. Now, so those are the two links we can see to CSRF and parameter tampering. There's a third link that we can't see. But the only thing that's stopping us seeing it is the CSS class. So the question is, what happens if we go to this URL? And in that case, this is all it took. So what should have happened is that the web app checked if we were authorized to access this page, but it was missing the check. So as a low privilege user browsing directly to the admin panel, we've got in, and we've got a flag here Desert Jack. Okay, so I've quite quickly there covered a variety of different web application floors, and I've shown you how we go about instrumenting the browser. So we've got the security tools intercepting it. I've shown you how we explore apps, how we can audit and exploit SQL injection, cross-site scripting, and access control issues. So I hope all that was useful to you, and I think we've got a little bit of time now for some questions.
Oh, brilliant. But thank you very much for the very insightful presentation. I'm pretty sure, just like me, everybody else has enjoyed it too. One of the questions is, Paul, that the site you have showed, XSSY, xssy.com, is that free for anybody to use, or is it something proprietary for your organization?
So it's xssy.uk.
Okay,
and
UK.
and it's free.
All right.
So yeah, it's a bit of it's a personal project. It's free. Anyone can have a go at it, can learn on it. There's video solutions to most of the labs. There's about 40 labs there, and there's a leaderboard as well. So as you solve labs, you get points, and you can work your way up the leaderboard.
All right. So nice way to learn about application hacking yourself too. Okay. So the second question is on the defensive side. What you have showed, I'm pretty sure it interests many of the users, because people are more interested in offensive side of the things, and trying to find out how to do the things bad guys do. So what would be your advice on the people who are trying to protect against these attacks?
So yeah, it's I think you need to do a bit of all three defense. So you need to do a bit of secure architecture, to do a bit of awareness within your team. You need to do a bit of auditing. And it's very likely that if you're not a big company, you wouldn't have the skills in your organization to do all this. So I guess I didn't come here as a sales pitch, but if you did happen to need assistance with these things, then my employer can assist you.
Brilliant. And that takes us to the top of the hour. And thank you very much, Paul, again, to taking the time off in the middle of the day for you in the UK. Thank you very much for doing this very insightful session for us. Really appreciate your contribution on this. Thanks again on behalf of ISC2 Colombo chapter. And for all of you who joined, thanks for being a wonderful audience. Thank you all. Thanks, Paul.
Pleasure to be here.
Thank you.